Hello class 12 science. In our last class, we have seen the numerical based on the equivalent conductivity and molar conductivity. Now today we are going to discuss a very important law, which is known as Kohlrausch law of independent migration of ions, we call it. So according to this law, the molar conductivity at infinite dilution of an electrolyte is equal to the sum of 4 conductance term multiplied with number of respective ions present in formula unit of electrolyte. So this is the law, and the equation for this is lambda, which is known as conductivity. So this is the molar conductivity, and this is infinite symbol. So molar conductivity at infinite dilution is equal to V plus lambda plus infinite plus V minus lambda minus infinite. Now over here, lambda plus and lambda minus at infinite are molar conductivities of cations and anions. So positive one is cations and the negative one is anions of an electrolyte, and V plus and V minus are the number of cations and anions per formula unit of electrolytes, and V plus and V minus are the number of cations and anions respectively. So in terms of equivalent conductivities, so this is in terms of molar conductivity. So in terms of equivalent conductivities, Kohlrausch law is also defined as follows. The equivalent conductivity of an electrolyte at infinite dilution is the sum of two values, one depending upon the cation and the other upon the anion, which is given by lambda equivalent at infinite equals to lambda of cation plus lambda of anion, where lambda C and lambda A are limiting ionic conductivities for the cation and the anion respectively. Now the application for this law, it helps to determine, the first application it helps to determine molar conductivity at infinite dilution for weak electrolytes. So we can find the molar conductivity. For example, the molar conductivity of weak electrolytes like acetic acid at infinite dilution can be determined by knowing the molar conductivity values for strong electrolytes like HCl, sodium acetate and sodium chloride. So we can calculate the molar conductivity of strong electrolyte by knowing the conductivities of these compounds. So for example, molar conductivity of acetic acid can be written as molar conductivity of HCl plus molar conductivity of sodium acetate minus molar conductivity of NaCl, all at infinite dilution. Now when you just put over here, because all these are electrolyte, when you put Kohlrausch law over here, in HCl we can get H plus and Cl minus. Similarly, in this sodium acetate, Na can be plus and this can be a minus, and in NaCl, Na plus can be plus and Cl will be minus. So when you just write down the individually according to the Kohlrausch law, the equations will be like this. Okay, the equations will be like this: 1, 2, and 3. Now adding 1 and 2 equation, adding 1 and 2 and subtracting equation 3 from it. So you need to add 1 and 2 and subtract this 2, whatever you get from this 3. So finally you'll get lambda m at infinite acetic acid equals to acetate plus H plus of the simple ion. So this will be the application of Kohlrausch law. It also helps to determine degree of dissociation of weak electrolyte. Okay, by using this formula. This is degree of dissociation, lambda m by lambda m at infinite. So it will be given by this formula, and it will be used to calculate the degree of dissociation for weak electrolyte. Now we are going to see the numerical based on this law, Kohlrausch law, because it's very important law. So the question is, calculate the molar conductivity of a solution of magnesium chloride at infinite dilution given that the molar ionic conductance of Mg2 plus and lambda Cl minus ions are 106.1 and 76.3 per ohm centimeter square per mole respectively. So this is the question. So from the question you can write down the given the value for this Mg2 plus is 106.1 and lambda Cl minus is 76.3 along with the unit. And from Kohlrausch law, as we know, lambda at infinite dilution, it is also denoted by naught, or you can write infinite also. MgCl2 magnesium chloride will be equals to magnesium ion Mg2 plus, and from this you'll get 2 chloride ion. So as we know, this number of ions will be written in front 2 Cl minus. Now the value for this and this one is given. Okay, so we'll just put the value and calculate the value for lambda, that is equivalent conductance. Here asked to find out, molar conductance. So molar conductance, when you just add, multiply and add this, you'll get to 58.75 per ohm centimeter square per mole. This is how we can apply this Kohlrausch law over here. In a similar way, we have got the assignment. Question number 2. This will be assignment for you. Question number 2 and 3. The molar conductivity at infinite dilution of aluminum sulfate is 858 Siemens centimeter square per mole. This is the this is also a unit like ohm per ohm. Calculate the molar ionic conductivity of aluminum 3 ion given that lambda not SO42 minus will be equal to 160 Siemens centimeter square per mole. And question number 3 is the specific conductance of 0.01 molar solution of acetic acid at 298 Kelvin is 1.65 in 10 power minus 4 per ohm per centimeter. The molar conductance at infinite dilution for H plus and acetate ion are 349.1 ohm per ohm centimeter square per mole and 40.9 per ohm centimeter square per mole respectively. And you're asked to calculate, the first one is molar conductance of solution, the second one is degree of dissociation of acetic acid, and the third one is dissociation constant for acetic acid. And this question has come in here as 2015. So complete this assignment and send it in my mail.